Hello, everyone. Today we have Adam Norton, co-director of the Nerve Center at UMass Lowell, where he's advancing how we test and evaluate robots, humans, and human-robot systems. His work shapes the standards that help exoskeletons and other wearable robots move safely and effectively from lab to field. Adam also facilitates the Compare ecosystem, chairs multiple ASTM committees, including F48 on exoskeletons, which is meeting this month. Currently serves on ASTM's board of directors. Adam, welcome. Excited to chat with you today.
Thank you very much for having me on. Looking forward to it.
So, as I always do, I am hoping you could set the stage for us. What sparked your interest in exoskeletons? How did you find yourself here today?
So my first foray into any part of this field was more in, I guess I'll say, like traditional robotics, more on kind of ground robot systems with manipulators, mobile bases, etc. And then as our testing center started to grow is when I learned more about kind of what exoskeletons actually were. And what I mean by that is that real exoskeletons don't look like how exoskeletons look in science fiction and popular culture, where it's not your entire body. It is a specialized part of your, like just your arm or just your leg. And that actually is what intrigued me most about it, that everything is very specialized in that, it's a system for your ankle, for your arm, for your hand, what have you. Because I think when I saw it in that form, I started appreciating it a bit more like a traditional piece of robotics, like one with a manipulator or with an actuator. And yeah, it just kind of grew from there.
Hmm. Do you have a robotics background then, and then you got into standards, or how did that work?
So my background is actually in fine arts, if you're talking academic
Cool.
background. When I first started actually out of high school about 20 years ago, I was involved in an art and robotics program just as a recent high school graduate that turned more into doing design for robot systems, and then eventually working in a robotics lab. My supervisor, Holly Yanko, had a lot of involvement in some of the early ASTM work on response robots for things with like EOD tags and disaster response. Naturally started finding my way into some of those meetings, and it just kind of gave in from there.
Fascinating. Um, this is definitely a tangent, but the kinds of things you're talking about sound very familiar uh, based on where I'm at here in Pittsburgh. Have you spent time in Pittsburgh?
Most of it for participating in the ARM Institute, Advanced Robotics for
Oh, yeah.
Manufacturing Institute, which is based there in Pittsburgh. Originally started out of Carnegie Mellon. So yeah, we work a lot with them in doing like test and evaluation of their various robotics and manufacturing projects. And we have got collaborators at CMU that we see, every now and then. But I know that they talk about, East Coast, West Coast for robotics, but it's always like, yes, there's Boston, yes, there's Silicon Valley, and Pittsburgh is almost always also part of that conversation because of its hub of robotics companies and academics and research and everything.
I'm glad we're part of the conversation.
Yeah.
Some of us here in Pittsburgh like to take the helm and say we're the robotics capital of the world. And I think there are reasons to justify that. But I'm also spending more time in Boston and appreciating all that you have going on there. I feel like Boston, the greater Boston area, I mean, Lowell's not far out. Um, it's like the exoskeleton capital of the world. Would you say that's fair?
It's definitely one of the major cities for sure. I know for like active body for active exoskeletons, Defy is a company we've had a long relationship with. I know they've been very active in the research space, and I think just this year they announced their partnership with Nike for kind of a consumer grade powered exoskeleton. That's one of the few systems I'm aware of that is like partnered at with a industry at that level to kind of go from their kind of research systems for military applications now into this more domestic everyday use. To me, that's like one of the biggest success stories out of this area for sure.
Yeah, that's super cool. We're familiar with Defy and collaborate on our open source leg project.
Yeah.
Um,
So sorry, I don't know how interesting this will be for other folks. Are you familiar with Elliot Rouse from
yes,
University of
yes, of
Michigan?
course.
Shout out Elliot if you're listening.
He will be featured in this season if he hasn't been
Fantastic.
already.
That's great. That's the funny thing too, is whether it's robotics or exoskeletons, this community is so small, even though it's huge, but we all know each other,
Yeah.
which is really fun.
Yeah, I agree. Building that community and celebrating it is definitely one of the reasons we do this podcast.
Awesome.
Yeah. So, yeah, let's get into like some of the nitty gritty. Given that we have the opportunity to speak with a standards and testing guru, how do you measure human robot performance in your work?
So, I think the simplest answer is to say, well, we rely on what the various commonly accepted methods are. But that's a pretty incomplete answer because this assumes that there is consensus amongst all of those different types of
Easier
methods.
said than done.
Exactly. But so, in the research space or in the standard space, there's various types of, objective performance measures that are recommended or commonly used. But for the exoskeleton space, while there are objective measures, there's a lot that goes in with subjective measures as well, right? Things like acceptance, trustworthiness, etc. But what's been really important to me in my work is there's always kind of looking at both of those metrics or both of those types of metrics to look at different aspects of evaluation where I'm always been interested in objective measures that you can use not to replace a subjective measure, but that can be, supportive or indicative of a subjective measure.
Mm.
So trust is a good example where there's a lot of these like qualitative trust questionnaires where people will respond, here's how much I trust the system or whatever the wording is. But if you couple that with measures of how they actually use the system of, despite the fact that it failed, they continued to use it for X number of hours or for this many tasks, whatever the measure may be, it adds a bit more objective measure of that subjective measure. Because my issue with subjective measures is that there's an assumption that the user knows what it is they think they're saying or what it is they think they're feeling about a system, where objectively you can, I think you can interpret a bit more about their, actual reliance or use of a system.
Very cool. You're speaking my language. So at Humotech, we're really focused on rapid evaluation of different prosthetic foot options. And we rely heavily on carefully designed subjective instruments. Um, and there's a constant back and forth between the subjective and the objective, and where they're similar and where they're different. It's quite a complicated problem. So how do you get how do you ground this? I mean, I think I understand, just based on what I know of you, that it comes down to task specificity. But could you elaborate on that a little bit?
Yeah, definitely there's a lot of application and task specificity that will influence, I think, the way that an evaluation is conducted. But at the same time, there's also a lot of very fundamental or fairly general types of performance measures that can be applied across the board, regardless of your application or your task. Whether that be different methods of interpreting EMG for muscle activation as a more objective measure, although it can become subjective on how you interpret those results.
What filters you use or whatever. Yeah.
Yeah, exactly. So yeah, it definitely can become very, very sensitive very, very quickly, depending on how you're applying it. But a lot of times, what we want to do is try to limit how we interpret the results of a test. So even if you are, trying to see, how much does a person accept this system? Acceptance is really important for a lot of like user adoption and what have you. If you're doing a really quick evaluation, someone's using a system for maybe 2 hours at a time, twice over 2 weeks, user acceptance is going to be very, subject to the novelty effect. All these kind of long-term adoption measures that we all really strive for are quite hard to truly evaluate without doing a lot of actual long-term studies, which are very, complicated and expensive. So as long as you are, I think, sufficiently limiting what your results are actually indicative of, and not overstating those results, it's at least a better way to interpret the results of your study.
I love that answer because, yeah, the context, the claim that you're trying to make is everything. I mean, if you come out with a product and you try to say this is the exoskeleton to end them all, the one exo to rule them all, you, there's a high burden of evidence there, for people to trust that company. But I think, exoskeletons, well, this is my theory, will be more rapidly adopted if we can solve more bite-sized problems with the technology.
I agree. And even back to one of my earlier answers about like seeing exos as being this thing that are now like focusing on specific parts of the body. I think it supports that type of mindset where, okay, we're very much looking at, one part of the body, usually under very particular conditions, for a particular segment of the industry, and just requires a lot more transparency and upfrontness of those that are doing those evaluations, that are reporting that data. And no, not talking down to any marketing folks, but we need to also limit the again, the interpretation of what that result means and how it's being promoted.
Well, I can tell you, as a scientist turned into an entrepreneur, this is a really hard balance to strike.
Absolutely.
um, so, uh, this is an off the cuff question. I'm not sure how easy it'll be to answer, but um, when in the development of a particular exoskeleton technology, do you think it's appropriate to start to have a conversation about standards?
I would say from day one. Now, I'll add an asterisk to that to say that this does not necessarily mean that we yet have standards to cover every aspect that you need to consider from day one.
Right.
But it's one of these arguments where people talk about, like when do you develop an interface for a human to control a robot? We go, well, you don't wait until the robot's being or is completed. You need to develop them in tandem. I think the same thing goes with standards, where if you know that eventually there is some type of specification, safety certification, performance standard, whatever it might be, that down the line you're going to have to consider because now you'll have a functional system. Ideally, those standards are there to not just be something you need to care about once you're ready for it, but that can help guide you in the development of your solution because you know that it is something you're going to have to care about. We don't develop standards to be roadblocks. We want them to be things that users of these systems can trust, but also that developers can look to say, all right, this is the performance metric or the criteria or whatever it is that I need to care about because the rest of the industry is looking to these. So if I don't care about them now, when I'm just getting started, it's going to be hard to backpedal later.
I like that way of thinking about it. I mean, for us, standardization is a cultural thing, right? So we all at Humotech try to develop and test our products in a way that's standardized. I mean, we don't know how else to hold ourselves to continuous improvement if we don't have a structured way of evaluating and improving. So it's just sort of baked into our DNA. And when I see a published standard that addresses something we're thinking about internally, I feel a sigh of relief. Like, oh, that's great. I can use this standard and have instead of having to develop our own sort of in-house standard. Um, but yeah, that is inverse or inverted from how I feel like standards have traditionally been viewed more as a barrier.
And I think a lot of this comes down to the type of standard you're talking about. So a lot of times, people look at standards as a thing that you need to meet. Otherwise, whatever, you won't be able to sell your product. And in a lot of cases, that is true. But one of the things that I like a lot about ASTM as a standards organization, and particularly for the committees that we work on, is their focus on standard test methods or standard practices, where it is not necessarily to say you need to design your system in this certain way, but here is the same measuring stick that everybody who uses the standard is going to refer to, so that one, a consumer could compare the results from this system and that system on that same standard test method. Or for a developer, following the line you were just mentioning, can say, well, if we continue to use this standard test method throughout the life cycle, we can track our performance and know that it is comparable to our last milestone and to the next one. So I think that kind of it changes the mindset of how people use standards. And it's something I've been trying to promote kind of throughout my entire research career, of like standards as an enabler as opposed to a barrier.
Yeah, that's great. Uh, I think we all take for granted that the fact that the measuring stick is standardized makes our lives a lot easier.
Right.
It just fades into the background of the things we think about. Um, hmm, Nate. So, could you describe? I mean, I know a bit, but for our listeners, can you describe your role in this kind of greater ecosystem of standards development, F48, et cetera?
Sure. So really the core of all of my research endeavors is all on test and evaluation, whether it be standards, whether it's, research grants, working with clients, et cetera. And because of the NERV Center, New England Robotics Validation Experimentation Center at NERV, or at UMass Lowell, that is also focused on test and evaluation, it means that all of our research projects, whether we're developing new capabilities or developing new test methodologies, all involves conducting some form of test or benchmarking, either as the product, meaning that we're intentionally developing test methods, or we're measuring our progress along the way. Because of that, we have a lot of great experience in doing field testing and doing controlled lab testing and doing human subjects testing. And all of those experiences are really useful for developing standard test methods, because a lot of times we are informing our test plans based on, again, things that are happening in literature, maybe some existing standard tests if they exist. And taking those experiences back to the standards organizations like F48 for exoskeletons, F45 for robotics, E5409 for response robots and drones, it gives us puts us in a really good position to provide a lot of that insight. And then in turn, if we are applying for a new project and say, okay, we're going to use this suite of standard test methods, some of which we helped develop from prior funding, that holds a lot of weight into our expertise and validity as a test center. So it's kind of always at the forefront of my mind, is how can we take the lessons learned from the testing we're doing for a particular project and utilize it for the rest of the community.
It's interesting you mentioned carrying a lot of weight. This is something I've been thinking about. Um, in the world of standards and testing, the brand of the facility that does the testing is actually really important. And for certain kinds of standards, there are marks, certifications that a company could pay for to have that stamp of approval. Um, how do you see this starting to evolve in the field of exoskeletons? I mean, we don't really have a mark yet, but are you involved in any conversations around that maybe coming to light?
Yeah, so I'd say there's kind of I don't want to say two schools of thought, but certainly two trajectories that we're seeing things. So on the one hand, I think there's some desire for something like a certification because of the weight that it can hold. But it also implies that there is some way to develop said certification and enforce it.
Hmm.
There's actually a newly formed task group within ASTM F48 that is going to be presented at that full committee meeting happening very soon. That is developing a new concept for some certification and training type program for exoskeleton users or developers. It's still kind of being formed. So there's definitely activities happening. On the other side of the house, though, we don't want things to be too prohibitive, right? We
Right.
don't want to limit innovation. We also don't want to incur a whole bunch of cost and effort if the return on investment is not ultimately worth it. So for a lot of other industries, say like robot arms, there's standard test methods. Like there's one out of ISO for robot manipulators for evaluating repeatability. You don't need to go to a third party test facility. You can run the standard test, provide the standard data, and you are essentially kind of self certifying. Certification maybe is a loaded term there, but at least self promoting. Here's the metric that I received on the standard test method. Now, that has become a pretty ubiquitous metric that if you go to buy a robot arm, their spec sheet will have some ISO metric for repeatability. We would like to see the same thing on exoskeletons, where within ASTM F48, we start to have all these different test methods that can be utilized, do not necessarily require third-party certification per se, but that a company could self-certify that, okay, here are the metrics we received on these standard test methods. Here are the specifications that we meet. We can provide the data as, the evidence trail, but it is something that we are proclaiming we have met. So I can see the power in both avenues, and one is not necessarily better than another. But it's something that is actively being developed in the community right now.
Hmm. Interesting. And the idea being, if you self-certify, that data would be made available to anyone with a legitimate request to see it.
I believe so. I'm sure that's a rabbit hole that can go
Yeah.
down into, what the data actually says and how it's presented, et cetera. But I know, at least from my perspective, I would always, of course, advocate for making it available and open.
Yeah. There's a dichotomy here where I see it play out in the prosthetics realm where I'm really focused. The standard test methods are not technically required. But if you're not conducting the, industry standard ISO tests for durability on your prosthetic components, that's going to raise some eyebrows. So there's, I think, a good, just natural incentive to do the tests. But the challenge I'm seeing, particularly for small companies, is that they're not well equipped to run those tests themselves. It requires equipment, it requires people, it requires expertise. And so, in a relatively small field where, um, there aren't a lot of options for where you can send your product off to be tested, um, I think uh, there there's a there's an actual benefit. Like I wish I could pay somebody to
Right.
go test my product for me. It's not necessarily like a gate I want to be required to go through, but having the option to do that, to elect for that higher level of rigor, could be useful from a marketing standpoint.
Yeah. And if I can turn that sentiment into a bit of self promotion,
Please
The
do.
the Nerve Center is set up as a core research facility. Users can essentially rent our testing services. We can conduct human subjects studies using standard test methods, using custom test plans, and that is one of our avenues as a research center. So as much as we want to make these things as reproducible as possible for others, you raise a great point, right? EMG systems are not cheap. Motion capture is not cheap. It's not easy to run. It's not easy to analyze. So there are facilities like Nerve and others and in the country that do offer those third party services. But I also was glad to hear you say that there seems to be at least like a general consensus, if not formalized, at least generally speaking, if you had one system with a spec sheet that said, here's all the tests we ran and the durability and whatever that we meet, and one that doesn't, that people know enough to like treat those differently.
Right, right. And I mean, the hardest thing when you're starting out is sales. So especially as a small company competing for market share with a bunch of large companies with established brands, what can you do to make your brand stand out? Um, I'm not going to name names, but there's a company that recently posted, an exoskeleton company, about meeting some standard, getting some certification I've never heard of. And I may be just poorly informed. But with ASTM having such a presence in this space, it seems like the natural organizing body to, yeah, take the lead on defining what those industry marks ought to be.
I agree. And again, about carrying weight, ASTM is a name that is known in a lot of industries. Been around a long time. All their kind of charter and how they function and their consensus based process is all freely available, and people know it. So there's also a lot of power, I think, behind saying we met an ASTM standard versus, oh, we met this other standard that someone else specified that, okay, maybe it was developed in a similar fashion, but if it doesn't have that, I mean, brand recognition, essentially as ASTM, ISO, whatever it might be, it frankly maybe shouldn't hold as much water as one might want it to.
Yeah. Yeah. I never historically, being trained as an engineer, I never thought of standards as having anything to do with marketing, branding. um, but it absolutely is essential. And you mentioned, a little bit about the business model of your center. Um, can you elaborate a little bit on this? Because I think what's really interesting is this question of who fuels the standards development, right? This work is expensive. So what type of organizations do you see in the exoskeleton domain caring about this, having an economic reason to fund standards development?
That's a great question because yeah, for those who are listening and maybe aren't aware, standards development is voluntary, and even participating, developing, all of it is a voluntary process, which can be problematic sometimes, right? It's hard to get people to do things even when they're paid to do it. So now, luckily, I think because the exoskeleton domain is so vibrant and alive, F48 has a very large membership that is all pretty passionately involved. I participate on a handful of other standards committees in other organizations outside of ASTM as well. That sometimes it's like pulling teeth to get something together. There is no shortage of input, opinions, feedback, and passion from the F48 committee, which is great. And luckily, that committee is made up of not just researchers like myself. It's folks from industry, folks from academia, folks from government bodies, folks from OSHA, like all of the different perspectives that you want to have involved. They care enough about it to dedicate their time. For industry folks, I'm sure this is some type of agreement with their supervisors about how to spend their time. For folks like myself, where we're running a test center that is fueled by grants and contracts, but also other agreements and services we do with industry. We need to be up on the standards so that we can provide services that match what they're looking for. And then in turn, we know that a lot of our work is very relevant for standards development. So it's a very natural fit from a research perspective. But I understand the maybe some of the issues with others participating where they need to make the time for it. I think it's helpful within F48 that since its start, it has been it's very driven by the committee. There's not another body saying that this has to be done. The committee is really pretty self-fueled, which is really great. With that said, I think the hope is that eventually there may be another body, be it government or wherever, that maybe says, in order to be classified as some type of system or whatever have you, that you need to meet these certain standards or run these test methods by, reaching these thresholds. Just because that at least shows that there is validation of the work that we're doing, that it's not just us in the committee that say it's good, but that, these larger governing bodies agree for the value of using them.
Right. So in theory, I guess a governing body could um, mandate or request that a standard be developed, and ASTM F48 would be the obvious place, given all the history of work the committee's done.
Yeah, and whether it's development of a standard or even I'll go one layer lower from governing body into just, let's say someone is on the hunt to procure a product for their facility, and they go, well, I look to the standards and go, all right, based on what these standards measure, I am only going to look at systems that meet all this criteria that I can define using a standard test method. If you can show me that your product meets each of those pieces of criteria, then now I'm interested in purchasing your product.
Right.
Yeah.
So I want to run with that example because it seems to me, I may not be fully up to speed, but it seems to me like there's a little bit of a gap still for that that buyer in that scenario. So say you have a large workforce with a high incidence of I don't know, back injuries, and you want to buy an exoskeleton. You spend a little bit of time on Google and you'll be overwhelmed with the number of choices, right? There's a lot of choices. But yeah, interpreting what's out there, the data that's been published, is not so simple. Um, where would someone go? I mean, I guess maybe they find their way to the ASTM committee, but uh, yeah, you're not an e-commerce platform. Um,
Yeah. But no, this is a great question. And there's a couple efforts kind of going on right now towards providing a better answer for that. So one, again, this is a bit of self-promotion, but it's part of ASTM F48. There's an effort we've been working on through their ASTM Exotech Center of Excellence, which funds some research for F48 into the development of a specification for minimum performance criteria
mm,
for exoskeletons. So it actually is we're still developing it, a standard that would set out a threshold of performance measured in a certain way over a certain set of tasks for a very, again, narrow set of exos, applications, and occupations that, if met, could separate your exo from the pack, let's
mhm.
say. Where, again, if you had 5 systems that met this spec and 5 that don't, that it would be meaningful in that the system is doing what it claims to do. Now, granted, this is a tall order because it requires us to truly minimally specify performance that can be considered common enough to, any quote unquote exo that fits this criteria, this is why this is a research project, because it's a very hard balance to strike. But now, in lieu of that, we actually did look at what are a lot of the promotional materials for a lot of exos that are available, and what types of claims are they making.
That's an interesting way to approach it.
So we looked at it to go, okay, there's a lot of claims about ergonomics. There's a lot of claims about range of motion, a lot of claims about injury prevention. And you can kind of put them into these different, categories. Every so often you might get an actual metric, 30% reduction
Right.
or whatever it might be. In even fewer cases, there will be a corresponding study that you can read to actually give you details into how that was derived. So there's definitely a lot of market speak that you can look at. It would, I would use it as a guiding principle, not a delineator at this point. And our hope is that through the development of the specification that we're working on and a lot of the other test methods and standards that are coming out of F48, that it will actually start to provide that standard measuring stick that others can use to sift through that information. Now, at the same time, the development of standards is voluntary. The compliance with standards is also voluntary, again, unless there is something else that requires it. What I am hopeful about is that I do think that within the world of exoskeletons, ASTM F48 is pretty well known. I mean, there's only a few standards bodies that really touch exos or things related to exos. Like you mentioned, some of the prosthetics organizations or organizations that do standards that apply to prosthetics that are also kind of in that same realm.
Mm.
But because of that, I'm hoping it means that as standards get produced out of F48, that they are being consumed by others outside of the committee and into the rest of the domain. Whether folks will start, publicly referencing them on their spec sheets, that kind of remains to be seen. But one thing I don't think we will see, for at least for quite a while, is some form of like database of, okay, here is a performance driven database, because all that performance is going to be gathered in different ways, unless you follow our standard specification.
Yeah, I mean, I was getting at this a little bit earlier with my question about like when is the right time to
Mm-hmm.
implement standards. Um, I liked your answer that it's never too soon. But we may not be yet at a point of critical mass where doing some of these standard comparisons market wide is really economically feasible. Um, but I'm glad you mentioned the prosthetic standards again, because I wanted to revisit that. There's an ISO committee that's been around for decades. I think touches what ASTM is working on in the orthotics realm. Um, and I do I do my best to try to create some connectivity there between the two committees. Um, I'm one of those for-profit business people that struggles to find the time to be as engaged as I would like to be. Um,
Understandable.
but I think the ISO Committee on Prosthetics and Orthotics has uh, a lot to learn from, particularly on like bench testing methods. I saw somewhere in ASTM updates recently that there's talk of doing some bench testing for exoskeletons.
That is correct. Right now, we've been kind of talking through the types of testing that would be used by some of these like specifications for performance requirements or what have you, and we've kind of been splitting it into more kind of human-centric testing specifications, which is more the angle we're coming from, we being the nerve center, and then more kind of mechanical benchtop type testing that are really trying to take the human out of the loop, at least in terms of being a wearer of a system, and looking at the applicability of even some existing standards. Like there's toy safety standards that have to do with like pinch points and, or material properties that I'm sure, like from the world of prosthetics, I imagine there's probably already some set of material properties or other types of requirements that are in there that we could learn from, and vice versa.
Yeah, great. Well, I've done my little bit of advocating for that because I think it's really important and incredibly nuanced. Bench
Mm.
testing is deceptively complicated. Um, because you're trying to simulate human use in a highly controllable way. But there's this dichotomy between consistency and real world applicability I mean, you have this in any kind of testing. Um, I wanted to ask about your philosophy on that sort of spectrum from the perfectly controlled lab test to the real world throw it on people and see what happens kind of test. How do you stay grounded in your evaluations?
Yeah. So it's interesting because usually it does get split into those two groups, right? Kind of controlled on the bench and then in the real world or in the wild is
Yeah.
maybe kind of usually the term. So I think there's a kind of a middle ground too, and this is one thing that I uh, like about the way that we try to approach things within my center is so at Nerve we're in a lab in all manner of speaking. But we are also trying to replicate real world conditions, at least in terms of whatever the salient parameters are, whether it's environmental constraints, temperature, noise, whatever it might be for a particular test. So that kind of middle ground is usually where we live in because there are things like you're saying you're not going to catch when you're in the very sterile benchtop test, but there's also things you're going to miss, understandably so, when you're out in the wild because you're in the wild and you can't instrument everything. This middle ground where you can be in repeatable conditions that are within reason, very close to a real world environment, but still under the context of we're running an experiment. You're not just a line worker doing your job and now you have to use this for several weeks. So there's a bridging there between those two types of environments that I think can get kind of the best of both worlds because to me that the key is really repeatable conditions, which benchtop testing, you can absolutely get repeatable conditions. In the wild, it's a little harder, but repeatable real world conditions, which I think is this kind of like in between in a test center type space. That's what we try to excel at because we think there's a lot of value in being able to measure the conditions you're in, but making them, higher on the TRL scale. And what I mean by that is, I know in the TRL definitions, there's the environment dimension where it's like one is like a close to a real world environment or whatever the phrasing is. I would love to see some more kind of formalized definitions of like taking those TRL levels and saying, okay, in order to be in a representative manufacturing environment, you need to match within reason, XYZ parameters. Those are the things we try to do within our testing and some of the other test facilities. We just don't have like formal definitions for them.
Hmm. Yeah, that makes sense. Do you do a lot of I'm trying to envision one of your tests? Do you do a lot of like perform the task with the exoskeleton, perform it without the exoskeleton, with the same person, and kind of compare results within subject?
Yes, I would say the most common setup is as you had just
Okay.
described. And then, like with any human testing, the higher the end, the better, but it can be very expensive, very hard. And you also have to control for, there's a lot of variability amongst humans. For a lot of our tests to date, which have been primarily funded by, Army or military applications, there are actually a good number of criteria, whether it come to age or height or other like physical fitness or what have you. So we can have a narrower set of a population. But at the same time, for even in a military application, you're going to deal with, the first day recruit and the, old seasoned general who are going to be quite different physically. But I think most important is actually knowledge of the task space. Which a lot of this comes down to like, training participants into how they can perform the task before just saying, okay, go ahead and try to do this mock drill task. We need to do, proper training. Wherein with you're going, into the wild and you're getting someone who's been on the line for 10 years and you don't have to tell them how to do their job. Obviously, you just have to tell them how to wear the exo. It does change the way that they might interact with it. So some of those balances are still a challenge in any of that kind of in lab testing.
So, in that hypothetical example, the exoskeleton may be highly effective for the one individual and the opposite, like counterproductive for the other. How do you like statistically reason about that? Um, it's not good or bad. Like the exoskeleton may be just appropriate for people with certain characteristics.
Yeah, it all comes down to how you're designing your study and kind of what type of result you're trying, what type of hypothesis you're trying to accept or reject. So for a lot of our testing, the other bit we try to consider is um, what can we minimally measure that regardless of uh, regardless of the person wearing it within our population or some of these other parameters, what should we still be seeing an improvement on? So one aspect from an EMG muscle activity perspective that we've been taking into some of our standards development has been, can we actually identify like a minimum set of muscle activations or particular muscle groups that no matter what your actual design of your system is, as long as it is of this certain type, made for this certain application, made for this certain domain, that regardless, it should still get this type of improvement on an EMG muscle or EMG measurement of a muscle. And that's been something we've been doing a lot of testing and looking back at some of our past data to try to justify. It's a very hard thing to, build consensus on, which is part of the standards development.
Right.
But it does allow us to say that, again, minimum criteria that this system is in fact, taking load off of the deltoid or on your lower back or whatever it might be. For the statistical analysis, a lot of times for our exo testing, we're doing what are called quick look tests, which are intentionally a small n, an n of 6 or 7, because it's not meant to be a comprehensive evaluation. It's more like we're doing a quick look to see, is this system trending towards being useful so that it can at least enter the next stage of investment dollars or what have you. Other groups, like if you talk to anyone out of Boeing, where Chris Reed at Boeing, shout out, he'll do a deployment over long periods of time, 20, 30 people, whatever it might be. They're getting really concrete, statistically significant data for their particular applications. So yeah, it's a balance, and ultimately, I just think we need to be very transparent when we're presenting our results. When my N is 6. I don't want to mislead anyone to thinking it means anything more than an N of 6.
Yeah. Yeah. That's a recurring theme in this conversation. I appreciate. But not everyone's trained in the scientific method.
Sure.
So our framing of our own results is really important. Um, Interesting. So, one of the benefits of the Humotech emulator technology we tout is the ability to blind the subject to the sort of make, model, and technology that they're trialing as they walk. Um,
My center just lost power.
no.
Sorry about that. We were really flowing there.
Well, folks, Adam's power just went out in his building, so we're going to wrap this one up. Thank you so much for chatting with us today, Adam. Fascinating discussion that we'll need to continue on standards development, and hope to see you the next time I'm in Boston.
Yeah, you're in the area. Gladly give you a tour. And thanks very much for having me. This was a great conversation.
Great. See you at the next ASTM meeting.
See ya.
Bye.